My name is Dorota Rizik, and I'm a lead organizer of the New York City chapter of Our Ladies. And so I'm going to give you a little overview of our chapter and also Our Ladies Global in general. And then I will hand it over to Federica to introduce the Rome chapter, and then also introduce our presenter who will be joining us shortly. So it's a collaborative event between two Our Ladies chapters, which is always fun and exciting. All right, so let's start with just what is Our Ladies in general. So Our Ladies, also known as Our Ladies Global, is a worldwide organization that promotes gender diversity in the art community via meetups and mentorship events, and we always try to keep it as a friendly and safe environment as possible. It's also been sort of shifting recently from not just art specifically, but just programming in general. I think that's in general where the world is headed. So it's good to think about other programming languages as well. So the mission is to promote and include more women and non-binary, programmers, coders, developers, speakers, and leaders. And the goal, the message and the motivation behind this is that more diversity and equity and inclusion, of people who are developing R packages and R code will lead to a better community and just more progress in general. And the Our Ladies Global community is very large. There's, when I looked earlier this month, there were 219 chapters across 63 countries and almost 4,000 events that have been created, which is just amazing to think about how wide of a reach there is across the globe. If you are interested in starting a local chapter of Our Ladies Global, it's fairly easy to get started. You can either email Our Ladies Global directly at info@ourladies.org, or you can ping them on social media. They're usually very responsive. So now a little bit more about my specific chapter, which is the New York City chapter. So our chapter has a co-organizing board that's made up of, I think, 9 people at this point. It's quite a large board, but that's because we do have over 3,100 members. So our events can get larger. And so we do our best to host monthly meetings, both in person and online, though it's been mostly online in recent years. And you can contact us very easily, either visit our website, ourladiesnyc.org, or you can reach out to us via email, nyc@ourladies.org. And yes, our co-organizers are these wonderful ladies and persons that just do very interesting works. Some do bioinformatics and biostatistics. Others, studied and got their PhDs in very niche specific areas. So it's just wonderful to be a part of a chapter and to help drive this wonderful community. A little bit of just the timeline overall. So Our Ladies Global was born in San Francisco back in October of 2012. And then a few other chapters popped up over the years across the world. And then NYC chapter was born in November of 2016. And then since then, it's been 8 years since then. And there's so many more chapters all over the world that we've grown so much, even as an individual chapter as well. And here is a visualization of that growth. So we now have, again, when I made this earlier this month, we had 3,155 members, and we've hosted a total of 110 events. And so our growth has been pretty steady over the years, which is always really nice to see. And we pulled this data directly from Meetup using a package called Meetup R, which was fun to play with. And yeah, you can feel free to join us. Like I said, we do a lot of online events. So if you are in other parts of the world, that's totally okay. We typically host Meetup talks or panels. We also try to attend conferences and workshops, and we do book clubs and also networking and socializing events. And those tend to be in person, but everything else is mostly online. And ways to get involved with the New York City chapters, obviously attend our meetups, or you can also follow us on our social media. channels. You can join our Slack channel and ask for resources or share resources, share job postings, things like that. You can write a blog post for us, which we would love if you are interested in just getting some practice with writing about R or programming or data science or data work. You could also organize. You could submit a talk idea for us, and we'd be happy to help you develop that and give you a platform. So, share and attend and join and participate. That's the best way to be a part of this community. And as promised, here are our social media handles. We are on Mastodon, LinkedIn, Twitter, I guess formerly Twitter, now X. You can also email us directly. And then if you are interested in joining our Slack, you can send us an email and then we'll share instructions for that. And I believe that's everything for my slides. Any questions? Anything else I see in the chat that someone mentioned that you've learned a lot from our ladies chapters? Yes. It's a really wonderful community to be a part of. So I think with that, I will stop sharing. And I'll hand it over to Federica.
Thank you. Thank you very much, Dorota. Thank you everyone for joining us today. It's now time to hand the floor over our esteemed speaker tonight event. We have the honor of hosting Dr. Hadley Wickham, Chief Scientist at Posit PBC, formerly RStudio, and a renowned figure in the world of data science. Dr. Wickham is not only an adjunct professor of statistics at the University of Auckland, Stanford University, and Rice University, but he's also a mastermind behind some of the most widely used tools and packages in the R programming language. His contributions to the field have revolutionized the way we approach data analysis, visualization, and software development in R. So tonight, Dr. Wickham will be talking about R in production, sharing insight and best practices on how to deploy our solution effectively in the real-world environments. So without further ado, please join me in welcoming Dr. Hadley Wickham.
Thanks for having me, everyone. Let me start my sharing. Okay. Hopefully you can see my presentation now. And open chat. Okay, so I wanted to talk about R production today. And so I'm going to start off with kind of a broad overview of what I think that means. And then I thought it would be fun to work on some code that I have in production, because I think it's a great example of code that even if you're not inside a company, even if you're just learning R or your school, still this is a great way to kind of practice some of the same skills you'll need to put code in production. And maybe if you have the same problems as me, solve one of your problems as well. So what is R in production? So I think of it, I'm not entirely sure what it is yet, but I can tell you what it's not. So typically when you're putting code in production, it's code that's sufficiently important that you're not going to run it just once. You're going to run it maybe again and again and again. And maybe that's because you've got a new data set coming in every now and then. Or maybe it's because you've got new data coming in every day and you want to run your quarter document, produce a dashboard, and then send that to your boss maybe every Monday morning. So your code is not going to be run just once, but it's going to be run multiple times, potentially over, months or years. And that's going to introduce some problems. And that's going to introduce some challenges, both in the way that you think about your code and the things you need to do in your code. The other thing that's really important about in production is that code in production is typically not going to be running on just your computer. It's going to be running on a server somewhere. And so there's, I think, a couple of differences there. The first is if you're using Windows, that server is almost certainly going to be a Linux machine. And there are a bunch of differences between small but annoying differences between Windows and Linux that you're going to need to learn about. It's also typically going to be configured as a server versus your personal desktop. So your personal desktop probably uses the language that you speak. It probably uses the time zone that you're in. And when you move to using a server, it's going to be using probably English or the ASCII locale, and it's going to be using some standard time zone. The other big challenge with running code on another computer is what happens when something goes wrong. Like, it's hard enough to debug your own code on your own computer when you can kind of put a browser statement in, you can do some little interactive experiments and figure out what's going wrong. But now your code is running somewhere that you can't interact with. And typically it's going to take, maybe 5 or 10 or 30 minutes to do an iterative cycle. And that's long enough that half the time, you send the code off to run, you go and do something else, and then you've like forgotten what you're doing when you come back to it. So that's the second challenge. It's not running just on your computer. And the third challenge is typically in production, your code it's not just you working on it, it's a team of people. You've got a bunch of data scientist colleagues who ideally need to be able to understand your code, and you need to be able to share work with. But also, you might be getting data that's produced by data engineers in your organization. You might be producing some kind of API that other developers in your organization are going to use to get model predictions from. And you're certainly going to be sending the results of your analyses, whether those are quarter reports or Shiny apps or something else, to the decision makers in the organization. And those introduce another set of challenges. And so today I'm going to focus on the first two, because these are ones that I think you can simulate reasonably well, even if you're not in an organization where you're putting stuff in production. And because I think these are really, like, if you're still a student, if you're just getting started with data science, I think having some of these skills to be familiar with so you can talk about them in job interviews, really, really useful, because it means that once you get a job, you can hit the ground running. You can get data, you can do stuff with it, and then you can automate that whole process. And so I'm going to show you a demo that's kind of motivated by my use of TikTok. And one of the people I follow on TikTok is this artist who produces these really cool sculptures. And I was like, oh, this is really cool. I would love to own one of those. And so I went to his website. And of course, the artist's name is Weston Lambert. And of course, every single thing is sold out. And kind of the reason it's sold out is because he's got like 600,000 followers on TikTok. So it's not so surprising. Like, I don't use TikTok that much. When he posts something new, I'm like, I don't know about this. But I really wanted to buy one of his pieces. And so I thought, well, let's solve it with R. And so that is what I'm going to show you today, my kind of production script that's going to like regularly scrape his website and then notify me whenever something new goes on sale. So this is very much kind of like a production type thing. You're going to run something regularly, and you kind of want someone to make like a decision or take an action at the end of it. So I think it's kind of a good little microcosm of production, and we're going to take a look at it. It's available on my GitHub. I'll just drop that in the chat for you all, and I'm going to show it to you, and then it's not very good, so I am ambitiously going to try and improve it live in front of you all, and so hopefully I won't get too stuck, or if I do, you can give me suggestions to get me unstuck. So I have this open in RStudio, and the first thing I'm going to do is use the Arvis package. And the Arvis package, if you haven't heard of it before, it's a package for basically turning websites into tidy data frames. So I'm going to go to his website, Weston Lambert, go to the available work page, which there's now basically nothing on it apart from a custom stand, which I don't know why anyone would just want to buy a custom stand. But I can take that, and then I'm going to read the HTML. And the way you work with Arvis is you select things using CSS select. So CSS stands for Cascading Style Sheets. It's the language that web developers use to describe how things should be styled. Like this should be a big black font, or this should be pale gray except when you hover over it. And the nice thing about CSS selectors is they also give us a way to identify elements on the page. Now, because this just updated since when I looked at it yesterday, it's not going to be particularly exciting because there's only one product available, but hopefully my code will still work. So basically what I'm saying is give me, and let's just, if I can look at that. Let me remember how to look at the source code. Let's just, you can't see what I'm looking at. I'm trying to bring it back. Okay, so one of the things which I'm going to try and show, if you ever do any web scraping, you can use the thing that's really useful is this thing called the browser developer tools. So I'm going to right click on this thing, this image, and we can kind of see all the HTML. So you don't need to know too much about HTML for this purpose, but the idea is that HTML is a tree. And so we're going to try and find something like in this tree that might be useful because, and when we kind of look up here, we'll see there's this division of the page with an ID called product list, right? And so that seems like a fairly good place to start. And so the way you select something with an ID is to put a hash in front of it. And so this is going to give me that element. And then I know everything inside of that is going to be a link, and a link is an A tag. So I can look at these products now. And unfortunately, there is only one. This would have been more exciting yesterday. But now I need to kind of look at this element. So let's see what this A is. Let's see what's inside of it. We need to try and figure out like where's the price. So you can see down here, this is kind of useful. It's got a class called product price, and it's got a class called product title. These, that's pretty suggestive. So I can use another selector. I'm going to say find all the elements with a class of product title and extract the text. That gives me custom stand. And I can do the same thing with the price. The price has some extra text and it has some dollar signs. So I just strip all those out and convert it to an actual number. And there's lots of other ways I could do this. In particular, this would be much easier if I could use readr, because I could just use readr pass number and that would do that all for me. But one of the things that's interesting about code in production is that your code's going to run somewhere else, right? And that means all of the packages you need and you run that analysis are also going to need to be copied somewhere else. So when you're running code in production, like minimizing the number of packages you use is really going to make your life easier. And I noticed that a few people are asking in the chat about my little arrows and triangles here. This is actually a font that I use, which I forget we set that appearance. I'm using this font called Fera Code, which provides ligatures. So ligatures kind of custom displays for. So if I put a space in between them, you can see that's just a regular vertical bar and a greater than symbol. Similarly, this is a less than sign and then followed by a minus. But Fera Code just makes that look a little bit nicer with the unfortunate side effect of confusing people when you show them your code. Now, unfortunately, today there are no sold out items. So you're going to have to rely on the fact that I figured this out earlier, that there happens to be when they're sold out, it happens to have an element on it called sold out. And then also I can figure out where the link to the actual product is. So I found out all these different variables, and I should say, I think if the scraping isn't kind of the main point of this talk, but I'll point you to a talk if I can remember where it was that I gave about this recently. Oh my God, I create so many. Here we go. Create so many functions. So if you do want to learn, if this is kind of interesting, you do want to learn more about web scraping, this is a workshop I gave a couple of months ago that will help you learn a little bit more. Okay, so where are we? So what have we done? And so I've now taken each of those pieces and I put them all together in a data frame. So this is not very exciting because there's only one row. But in principle, what I want to do now is say, well, let's take a look at the products I saw last time, which I saved as a CSV file. And so last time, there were these 10 things for sale, also mostly sold out. So what I want to do is find which ones are new and are not sold out. And so I'm using this link as kind of a unique identifier, right? So I'm saying, if I've seen it before, don't tell me about it again. And so what I'm going to do is find all of the rows where sold out is missing, so they're not sold out, and the link is not present in the last set of links. So this should find, I should add a comment here, find all products that aren't sold out, I didn't see last time. And then I'm going to create, if there are any products, I'm going to create a little message. Which didn't work. And now I have to figure out why didn't that work. And upload. So let's just try one of those. So that worked. Oh, I see. When I looked at old, there already was a custom stand there. Okay, so it's doing the right thing. It's saying there are no new products that you haven't already seen because this custom stand was on sale last time you checked it. But I'm going to update the products.csv file. And now, since this is on Git, which we can't see in the share, let's just see if I can change that quickly. So in the Git pane, now effectively what I would do is update products data. And actually, before I do that, I should probably just make sure, I should have done this when I started, but I probably want to get the latest changes. And then, okay, so now there isn't actually any changes in Git because, which I'll show you shortly, I actually have a GitHub action that is running this automatically. But this is the basic idea. So what have I done? So I scraped the website with Harvest. You saw that, and I created a tidy table of data. The next thing I'm going to show you is how I repeatedly rerun this. So if we go to the GitHub site, and we look at the commits, you'll see this repo actually has 319 commits in it. Most of them have the same, not very useful title. But if I look at one of these, you can see this is updating a CSV file with the changes to the website. So just having this, just this alone is quite useful. Right now I've converted a website into a CSV file and I'm tracking the changes over time with Git. So now at least you could like look at this and kind of say, well, how often do things actually sell out? And how often does he add new mystery sculptures to the website, or you could maybe start to do some more analysis, like, well, if I want to look at his website, what time should I go to make sure the new products haven't sold out yet? And the reason this works is I use a GitHub action. So GitHub actions are something that are free for everyone to run on open source repos, at least, or publicly available repos. And I've set this one up to automatically run, what this means is every 3 hours. So every 3 hours, what's it going to do? It's going to check out the repo. So this is kind of common when you're running something in production. Often you're going to start with a completely blank slate. You just get given like a Linux machine that has nothing on it, basically. So the first thing I'm going to do is check out my code. Then I'm going to use some code that we provide through the rlib actions repo that's going to install R. So every time this runs, we're going to install R. We're going to check out my code and then install R. Then we need to install all the dependencies I need for my package. And now I can actually run that script. So that's not quite enough, because I also need to check that back into Git. And I wish I could tell you how I got this code, but I can guarantee to you I did not write this myself, because I do not remember doing that. And I don't remember why I need stuff like this there. But I think I wrote a comment here that this is the kind of idea that I copied from Simon Willison, and he used a slightly different approach, but pretty similar idea. So what I've done, so what's going on in the script, I start with a completely blank slate. I'm going to get my code out. I'm going to install R. I'm going to install all the dependencies I need. I'm going to run my script, and then I'm going to save the results. And if you go back enough in time, well, there's 300 commits here. I don't know how far. We go back a while, quite a while. So I guess this has just been running for a while. Okay. You can see like there's a lot of initial commits where there's quite a lot of iteration to get this working correctly. But I eventually got it working correctly. And once it did, it just has been running tirelessly every 3 hours, updating whenever the site changes for the last 8 months. So I see Philippe in the chat asked a good question, which how does it figure out my dependencies? I actually created a description file here, not because this is a package, which always has a description, but just because we've got some easy tools to install dependencies if you do have a description. I think one of the things you probably should do, one of the things, the downsides of this approach, is it's going to install the latest version of your package. It's going to install the packages that are currently available on CRAN, which is not a great idea. So the other thing it's supposed to do is send a push notification. Unfortunately, this push notification, I never actually got it to work. But I did a little exploration yesterday, and I think we can change it to work. I realized a couple of minutes ago, my goal was to like do this push notification and then show you on my phone. But I forgot that I also use my phone as my webcam, so that's going to require some gymnastics. But I'm using this repo, which I'm going to, from John O'Carroll. Oops. To send it using this free website called Notify, whose only feature is that it's free, basically, and it does just what we need. So we're going to just try. I've created and Notify is basically public to everyone. And so the way we get around that is we create a topic name that's basically just a random name. So you can sign up for these notifications if you quickly copy this URL down. I can put it in the chat actually. It's not a big deal. And now from R, I can run some code and run that. Oops, I think it. Oh yeah, I think I can install this. Let's run that. And then hopefully I got a link. I got this notification. And so the cool thing about this is, as well as being like a desktop app, it's also an iPhone app. So I actually get a push notification. So let's, well, it came to my watch, which I can't show very easily, but you can see I got a notification. I don't hold my watch at the right angle. I got a notification on my watch telling me that something has happened on that website. So I think this is pretty cool. Like, I've now got all the pieces in place so that when something changes on this website, I'm going to get a notification and I can actually go and use it. And that did, in fact, work successfully for me. And I purchased this sculpture, which I really, really like. Okay, so I wanted to, that's the code. So let's maybe just talk a little bit more about, I think, like some of the challenges you'll face when putting code into production. And then depending on how long that takes, we can kind of come back and maybe make some improvements to this code. So let's think about some of the challenges faced with this. And for this particular example, I'm going to ask you to imagine that you're a data scientist working for an ice cream store. And all of my images are drawn by Chat GPT 04, which is notoriously bad at words. So please enjoy the terrible spelling as we go. So you're a data scientist for ice cream company. You want to help them predict how many ice creams they're going to sell tomorrow, maybe based on how many ice creams they sold today and the weather forecast for tomorrow. And so you've written a bunch of R code, you've fit some models, you've made a nice Quarto notebook. Which I love the variables that it's decided are important, which is like humidity. Well, maybe that's a good one. And holidays, that's probably a good one. I've got no idea what Sims pop is or Seamer or Commodores, sure. But you've made this wonderful notebook, and now you want to like run this every day so that the people who are in charge of making ice cream in your organization or shipping it out to the store know what to do. And so now you want to create this kind of like productionized process that every day you're going to try and do exactly the same thing. And so what are the challenges to doing that? Well, the first challenge is that the data is going to change. I mean, hopefully, I think this is probably the most obvious, right? That you know, like in winter, sales of ice cream are likely to drop. But if you don't have data about winter, like if you don't have enough data going back into time, the first time you see something unusual like that, you're going to get bad predictions from the model. Another thing that might happen is that the schema of the data might change. So the schema is kind of the definition of the data, like what are the variable types, what are the variable names. So maybe you've been working with data like this. Obviously, your company does not make weather forecasts, right? So you're downloading this from some API, somewhere on the internet. And one day it changes. So what I want you to do is just take a minute, think about this yourself. You might put ideas in the chat if you want. Like, what's the difference? Well, what are the differences between these two data frames? And what do you think the impact on your code is likely to be? Like, I haven't shown you any code. I just want you to imagine, like, what do you think these changes are going to do? So let's just take a minute. And what I want you to do, see if you can identify the three differences and think about what's the impact going to be. See lots of ideas coming up in the chat. I think you have got them all. So what are the differences? So the most obvious difference is that temp and temperature have changed. Temp has changed to temperature. So what's the likely impact of this on your code? You're probably going to get an error message, right? Which is good. Which is kind of the best thing that can possibly happen compared to some of the changes we'll talk about next. So so that's good because it tells you that the format's changed and you have to go back to your code and fix it. What else has changed? Well, we've changed from a date format, the ISO 8601 date, which is used commonly in Europe, to month, day, year format, which is used commonly in America. So what might happen here? I think you've got a few different options. First of all, your code might just error because you've hard-coded that you expect it to be in year, month, day format. It might just work because it's automatically guessing the date types from the column. Or in the worst possible scenario, it might guess that these are day, month, year variable data. So in this subset of data, this is all valid dates. This could be the 5th of January, the 5th of February, the 5th of March, 5th of April, which, as humans looking at this, we're likely to say that seems implausible. This is definitely year, month, day. But if you're very unlucky, it might automatically guess the wrong date. And now you're just going to get nonsense. Your code isn't going to error, it's just going to give bad results. And that's the same thing that might happen, that's almost certainly going to happen with the last one, where it's changed from Celsius, centigrade, to Fahrenheit. Like, this is still a number, it's still a valid number, but if you fit your model on Celsius and now you're giving it Fahrenheit, you're going to get terrible predictions out of that. And you're not going to know that, right? There's not going to throw an error, you're just going to be getting really bad numbers out of that. And so that's kind of like the worst possible scenario for code that's running in production, right? It doesn't error, it just silently gives the wrong results. Okay, so those are the first two challenges. Like, you might get data you've never seen before, or another place this might arise, for example, is maybe originally the ice cream store was only open on the weekends, and now it's also open on weekdays. And so you might get new data, maybe the day of the variable, the day of the week is something that's important, and now you're going to get new days of the week you need to make predictions. The schema might change, or maybe one of your dependencies changes. So maybe there's a great new version of your favorite package comes out, and it adds a bunch of cool new features that you love and think are amazing, but it also breaks one of your existing plots because something no longer works. And maybe that's because you were relying on a bug. Maybe it's because the ggplot2 developers made a mistake. Maybe they made some deliberate change. But for whatever reason, your code no longer works because you are installing the current version every day. Now, there's a really good fix for this, and that's to use rn. Let's see if I can do that quickly, just to show you. And the basic idea of rn is it's going to capture all of the versions of the packages that you're currently using. So there's only one package here, harvest, and one package here that I'm using, notify, but it captures all of the packages that those packages depend on as well. And it records all that information in a lock file. And now in my GitHub action, instead of set up R dependencies, I could use set up R something else whose name I've forgotten, and I will just quickly look that up. Actions, set up RN. Okay. So I've changed this, so there's now an RN lock file. If I look at that lock file, it's a JSON file, but most importantly, you can see it's got the version of every single package I have installed. So now when this runs on GitHub, it's going to run exactly the same versions of those packages, even if new packages are released over time. So by and large, like dependencies changing, I think is kind of a solved problem because you can just capture all of the dependencies at one point in time using RN. Well, there's some other similar tools, but I think RN is my favorite. Another thing that might change is maybe the entire platform changes. So maybe there's a new chip that comes out, and maybe there's some difference in how it does linear algebra, and it gives slightly different results to your model. Or maybe the operating system changes, or maybe the C libraries that the packages you use depend on change, or maybe the version of R or Python changes. This is much, much, much less common, particularly these days, but there've been some particularly famous examples in the past where I remember something, I guess, like 20 plus years ago, where an Intel chip had a bug in its maths operations, so a bunch of people got incorrect results in their spreadsheets. So this is not very common, but good to be aware of. And the way that people tend to fix this, solve this problem in practice, is to use containers. This is why you might have heard of containers that basically just captures an entire operating system in a box. You can just ensure that every time your code runs, it's running on exactly the same version. The other challenge that you might face is the universe might change. So in the case of an ice cream store, like maybe it's because your shop changed location. And obviously, like if it's now on a beach instead of in the city, like the sales patterns are likely to be very different. But your code is just going to keep going. It's just going to keep producing. It's going to keep fitting the model that worked for you originally. Maybe that model doesn't fit very well, but it's not going to give you good results. And worse, it's not going to give you a clear error that says, hey, the model's wrong, because models kind of by their very nature can't do. And so you might have heard of terms like concept drift or model drift or data drift. But I think the basic idea is that like a model is by its very nature an imperfect. It captures reality imperfectly. And it captures it best at the time it was fit. And as you get further away from that time, like more and more little errors are going to creep in. So even if nothing major changes, like if you only fit your model once and make predictions from it, those predictions are going to get worse and worse over time, because this kind of, you've somehow implicitly fit like a Taylor series approximation to the universe. And as you move away from that approximation point, it's going to get worse and worse and worse. And the way you kind of resolve that is you can't just like set and forget a model. You're going to have to regularly check it. In the case of like my little production thing, I think what the universe changing would look like is this looking different, like the structure of the HTML page changing. And the way that Arvis works is if it doesn't find anything, if I deliberately introduce a misspelling, it's going to report nothing here. So I think this is something in my code here. What I really should be doing is saying like if length products equals 0, I need to throw an error. And that means my script isn't going to continue running even though the structure of the website has changed and I'm now just getting nonsense results. And the nice thing about doing an error like this is that when you are running in batch mode, so if you remember in my, oops, I have this open here, in my scraping script, it calls RScript. And if you call RScript instead of using R interactively, whenever there's an error, it's basically going to quit and it's not going to run any more code. And when that quits, it's going to notify GitHub Actions, and then that will give you an error that you get notified about through your GitHub notifications. So a lot of making, I think, writing production ready code is thinking about like how could the inputs to my code change in such a way that the code still works, but it gives me nonsense responses. So another thing that maybe you could do here is something like if the price is less than 0, and at least encourage you to come and like take a look at that problem. The last challenge with like repeatedly running code in production is that over time, your requirements are going to change. And in some ways, like the best and worst thing that can happen to you as a data scientist is if like something you've done, some dashboard you've created, some model you've built becomes so important that the executives in your company start to rely on it. And that's awesome because your work is having a very direct impact on the company. But it also means those people are going to be looking at it and emailing you with requests to change it. And I don't think that's a problem necessarily, but I think like dealing with that kind of like iterative flow of requests is not something that like data scientists tend to be trained in. It's not something you learn in university. So how you like keep track of those? How do you make sure that you continue doing the work that is important to you as a data scientist, even while you get requests from like several layers above you in the org chart to do things urgent? Like how do you balance that? How do you balance working on the things that are like important versus the things that are urgent because someone else higher in the org chart than you really wants them? So those to me are kind of the things you need to think about when you're writing code that's like running long term. So let's just take a look at this. We've already kind of seen an example of the data changing, right? Like I looked at that today, and there was only one product there, which made this much less interesting than it might have been. The schema, I mean, maybe in this case, it's kind of hard to say whether it's the universe or the schema that's changing, if the HTML structure of the website changed. So one thing that makes me a little bit more comfortable about scraping this, as you can see, it's powered by Squarespace, which is a big website that powers tons of websites. So I kind of know behind the scenes, like this is all automated. Someone's not manually handwriting this HTML. It's likely to be generated by code, and it's unlikely for that code to change in the short run. It might change in the long run, and that is why I really should add code like this to check that it hasn't. Because otherwise my code will just continue working, return a 0 row data frame, everything else will work, but I just don't get any notifications. So we can protect against changes to dependencies, as I said, by using RN, which basically works by recording all of the changes. I've already protected against changes in the platform because in my YAML file, well, I've almost protected against it because I say run on Ubuntu latest. And so this is the container, this is the operating system and all the system libraries that GitHub is going to use to run my code. And we can maybe figure out what that means and how often that changes. So I could actually, if I wanted to be safer, change it to a specific version of Ubuntu. So now, rather than using the latest released version of Ubuntu, it'll always use Ubuntu version 20. And in this case, I don't think it's that important because none of this code is like, it's very, very simple code. It's kind of easy to see what might go wrong, and I don't think the operating system is likely to impact it. And like operating systems change relatively slowly anyway, and I don't expect to be running this script for years on end. But again, this is something I could do. I could lock down a specific version of the operating system so to isolate that from the source of all possible other changes. So that's the platform changing. We also talked about the universe changing. In this case, the universe changed because I successfully purchased the artwork that I wanted to purchase, and then the script is no longer useful. That's, I think, a not uncommon result of a data science project, right? You actually might
Is Hadley frozen?
Okay.
sorry about that. I just lost power, but I am back. Hopefully we will not lose power again. Okay, let me share my screen again. Oops. And let me regain my thought. We talked about platform, the universe. Yes, in this case, the universe changed. The data analysis and production has desired effect, and I could now effectively wrap that up, right? Not super uncommon. Like sometimes you do an analysis just to, get something to change. It's changed, and then you're done. Or maybe that was the requirements changing, because in this case, I got what I needed out of the analysis. So I think that's probably a good place to start. I kind of showed you a few ways I could make this code more kind of production ready by adding in more errors so that when something goes wrong, I get notified about the script. I also spent a little bit of time yesterday figuring out how I could get rid of this dependency on the notify package to make my code even simpler, which I should put in there because it's kind of nice. And that just means I'm no longer using the notify package, but I'm using the HTTR package to do this directly. No real reason to do that, except that I think if you were doing this and just putting this code in production in a real company, it gets pretty hard to use code from like random GitHub repos because that code could change at any point, and many IT departments will not let you like just use random code from the internet. So I think let's stop there, and we've got some time for questions. I will not tell you about some of the challenges of not just my computer, but you did see a few of those along the way. And I will tell you the thing that is hardest to debug is when this doesn't work, right? Because when this doesn't work, all that happens is you don't get a message, which is obviously very difficult to detect. So I think any of these problems, like you should expect some pain and frustration, especially when you do it the first time. I think there are a lot of it, like one of the advantages to using tools, commercial tools like Posit Connect, is that they actually help you figure out when something didn't run and didn't do something, which is the hardest case to figure out. So let's stop there and take questions from Slack. Federica, do you want to ask them, or do you want me to just pick them out and read them?
I would just unmute all. So if you like, if they want to ask you directly a question, they can. There is something in the chat already. One Avis, would you like to read the question, ask the question yourself?
Yes, I can read. I have two questions. The first one is about this web scraping. Apart from R Selenium package, are there any other R packages which can scrape JavaScript managed web pages? And the second question is about this data drift, how to automatically identify such drifts. Thank you.
So these are my answers. First, Arvis now has experimental tools for scraping live pages that run JavaScript. So this actually runs a web browser in the background and interacts with it. So you can interact with any website exactly as you're a real person. To echo one of the questions earlier in the chat, I will not be telling you how you can do this to scrape Ticketmaster or other places like that. I will say these techniques generally don't work on any website where you can imagine people really care about scraping, because like Ticketmaster, etc., just wants to stop people from scraping it because they don't want to enable scalpers. So they introduce a bunch of like tools to stop that, which of course you can overcome if you're creative enough, but I would never suggest such a thing. Like identifying data drift, I think is more challenging. I'm kind of surprised there's not more research and interest in this. I think the best thing I've come up with or was suggested to me was this applicable package that Max Kuhn suggested. And basically what the applicable package does is every time you make a prediction, it tells you how far away from the training data is that prediction. And so I think like that just seems like something you probably want with like every prediction, right? Like, am I making a prediction that's solidly in the body of data that I've seen before and I can feel really, really confident? Or am I making a prediction that's a very long way away from the data that I used to fit the model? In which case I should, I should take that with a grain of salt, or maybe if it's even far enough away, I should automatically flag that and encourage people to refit the model. In a sort of a similar vein, Vedava from my colleagues Julia and Isabel help you set up this like regular cycle of like model assessment and monitoring, so that when your model does drift away from reality, you've got some chance of like catching that.
Isabel, would you like to ask the question directly? Maybe. So she said, I've used the package that notifies you in Slack and that you work great. Maybe you want to say something?
It was not really a question. It was just that there was an alternative to use for the notifications instead of the notify.
Okay.
Yeah, there's like a ton of packages out there. I think Slack-R is useful. One of the things that I liked about Notify is, I think the only, like, there's just so little there, but it's like free and you don't have to worry about, like one of the other things that's like painful about putting stuff in production is how do you get all of your credentials shared correctly? And so like if I was going to publish to Slack, like I need to somehow get either my Slack username and password, which would be kind of probably a bad idea to put that on my GitHub, or some kind of like token that Slack could give me, and it's just like a bunch more work. But I think if you're doing this like kind of inside your organization, tools like this are really useful.
I was running it from my computer, but the only step that was not automized was when the code was run. That step was still not. It depended on when the data was generated. It was sequencing data, so I was waiting for the sequencer to finish. But then the good thing is that the lab would get notifications, and especially it was about the results.
Yeah.
If some of the data was out of the threshold that we were expecting, the lab will know that there was probably an error in sequencing and they could fix it. So it would, and I put everything in
Nice.
GitHub except of the credentials, that part was ignored. So the file with that was ignored, so I didn't have that problem.
Yeah, another package that if you're just doing that kind of like long running thing locally is BPAR, which will like make your computer play some music. That's like super low stakes, but I think that idea of like notifying not just you, but potentially a channel on Slack is like a really powerful
And
idea.
even I was adding like plots, so they could see the results. That was the problem. So they could really see, hey, this plot, like it makes no sense. Probably we have an error because there was a manual, like an input of data that was manual, that was created by the lab technicians. And if they would make an error when they were preparing that file, the data make no sense. So I needed to tell them as soon as possible, your data, it makes no sense. Fix the file.
Yeah, makes sense. I see David asked a question about how you manage credentials in production. There's like two ways, I think. There's the way that's not particularly secure. It's okay. It's like, okay, it's fine. That works everywhere, and that is to use environment variables. And so like locally, what that means is you could run a script like edit our environment, which I'm not going to run because that will show you all my environment variables, which contain a bunch of secret stuff. But you can like put them like the kind of the basic idea is you have this one file, like your .r environment file, which contains a bunch of things that never gets committed to GitHub. And then on GitHub, under settings and secrets and variables, you can add these something. This confuses me. I think I want a repository secret. So once you've set it, you can never actually see it again, but you can't edit it. You can only replace it. But you can, there are ways you can read that into an environment variable in your GitHub Actions. So you have to be careful to never like print that out. Although GitHub does take some basic precautions to make sure you don't accidentally do that. But that allows you to have kind of something that's like secret locally and secret anywhere else. So this environment variables thing basically works everywhere, but it's kind of a pain because it typically relies on you doing some kind of copy and paste. One of the things that we've been trying to work on in Posit's professional products is making auth kind of just work. So if you're using Databricks or Snowflake, all of the credentials kind of magically flow through. And I think that's the, like, in like a well-resourced organization, that's the way it should work. Like your administrator should kind of take care of making of all of this auth stuff so that you don't need to worry about it. Until we get to that point, environment variables that you do whatever you need to do, wherever you need to do it, basically.
Okay, great. Thank you. There is a question from Eugene. I don't know if you want to ask him, but I shared the question as well. So I wanted to ask myself, what is the future looking like for R?
Yeah, I'll preface any remarks. I think like there's this Yogi Berra quote, I think. Like making predictions is hard. Yeah, I like this. It's tough to make predictions, especially about the future. So I don't know. I don't know what's going to happen. I would say, like, it feels like I think one of the things that make it hard to kind of like get a sense for like what's up with R is I think like the absolute number of R users is still increasing, but the percentage of people using R for data science is decreasing because the number of people using Python for R is increasing faster. Now, like And I think like like, you know, don't get me wrong, Python is a great language. And I think the reason, you know, more and more people are using it for data science is it's a great general purpose programming language. But I don't think it's reasonable for there to just be like one programming language. Like, I think it makes sense to have some general purpose tools and more special purpose tools. And while R is like a general purpose programming language, you can do anything you want in R. It's definitely like particularly well tailored for the needs of data science. And I think the design of R means, in my biased opinion, that tools like ggplot2 and dplyr are always going to be better in R than basically any other programming language, because no other programming language gives you the flexibility to implement those sort of APIs, which give you this very fluent interface for exploring data. And I still, you know, still think ggplot2 and dplyr are better than their Python equivalents, and I think they always will be. Like, what is that? Is that like enough for R to survive in the long run? I don't know. Like, I hope so. I have no intentions to stop using R. Like, I will continue to, you know, do my darndest to make sure that R stays competitive and around in the long run, because you know, I love it, and I think it's a really great environment. It's hard to tell the impact of like generative AI on this, because in some ways it massively reduces the cost of switching languages, because you can ask it to help you learn to program in languages. And at the same time, like, I am also, like, the thing that makes it easier for me to keep going is like when I started using R, it was like maybe they had like 1% of the users today. So I've been using it for a very long time, since before it got popular. So it doesn't, like, maybe if it goes up and then declines, but I don't know. Maybe that's okay. And I kind of hope that, I don't know, my hope is that like Posit as a company, we get really good at producing Python tools. And so that when Python data scientists are at a company, they say, yeah, we really need to buy Posit products. And then that just like automatically supports all the R users as well, because there's always going to be people who love R at Posit and you know, devote their lives to it. So maybe, like, my hope would be that sort of becomes a Trojan horse, that we can make it good enough that Python people demand it, and then the R users just get a free ride, which is very much not what happens today. So I don't know. I'm still, you know, I don't know. It's tough to. I don't know. It's tough. It's definitely scary. It's definitely worrying, and I think kind of compounded with me personally, for like at least the personal. Twitter is dead to me personally. That just means like it feels like the R community has shrunk massively, because I don't have that that regular interaction with so many people from around the world. And so it's just all of these, you know, plus the pandemic, just everything kind of, I don't know, happening at once. Like, thing changes, the world changes. I don't know. I think it's probably worthwhile for everyone. Like, you know, don't put all your somethings in one something. I'm blanking on the idiom. But that, you know, it's useful to be diversified, right? Like, you want to be really strong in some areas, but be always willing to learn. Like, at some point in your career, you're gonna have to learn another programming language. R is gonna go away at some point. Maybe it's in 10 years, maybe it's in 50 years, but I don't imagine it existing for the rest of humanity. So you just have to accept, like, things change over the point of your career, the course of your career, and that's fine. And I don't know. That's a very long, rambly, vague answer, but that's the best I've got.
Yeah, thank you. Maybe sometimes can be annoying when you you get proficient and now some fluency in one language, and then you need to, but if you do that, like that you keep looking at other languages while you are using your favorite one, it might be easier. But it's hard.
Yeah, and I will say, I think one of the things that impresses me most about JJ, who's my boss, who wrote, the RStudio ID and many other things, is that pretty regular, like every 5 years, he just throws himself into a new field, potentially a new programming language, and just tackles something that he's like never done before. And I think that's an incredible skill. I wish I had that in some ways. I can like throw myself into the unknown and to go back to that point where you're like, everything is so hard and so frustrating. And to do that like again and again and again, I think that's like just incredible. It's kind of like a superpower.
Thank you. So there is more questions. Alex?
Yes, hello, can you hear me?
Yep.
Mm-hmm.
Yeah, Hadley, first of all, thank you for your great book, R for Data Science, and it's really helped me for my career. So thank you so much. And my question is, for example, if someone works with sentiment analysis and he uses both R libraries and transformers libraries, what is more reliable and robust for production? Would it be better to use your own code, your own R libraries, which don't depend on external APIs, or you should experiment with transformers? So how you make result more
this
stable?
is always the balance of taking dependencies. Like the more dependencies you use, the higher the chance of something outside of your control going wrong. But the fewer dependencies you use, like the more work you have to do yourself. And you have to kind of balance that, like what's the likelihood of me doing this correctly and performantly versus something going wrong with something else. I would say my hope, and if this is not true, I would hope we would fix it, is that like reticulate plus RN, which also captures your Python dependencies, should give you a pretty robust experience. And at least in the terms of like, everything works today, and if it works today, I want it to keep working tomorrow and the day after, forever and ever. It's going to be more challenging to like debug when things go wrong because you're crossing multiple language barriers, but I don't think it should cause problems in production. And ironically, in some ways, like I know reticulate makes it much, and Keras and similar wrappers make it easier to install things in Python sometimes from R than in Python themselves, because like one of the things that we believe in is that like installing software shouldn't be a pain, and so there's a lot of effort put into like Keras. Keras, I'm sure, has a like an install Keras function, which we do our best to make sure works reliably.
But now it's Keras 3, so it's much better. Much better. To solve some issues, I've turned around some installation issues, setting a Python path. Then I changed the machine, so I haven't. So I had to do that again. But so Keras 3 has this issue. So that's a nice, very nice Python connection. Okay, thank you very much. I don't know if you got time. We have a couple of questions more.
Maybe I have a good answer for one of them. So could we do the question from Melissa? Melissa, I don't know if you want to ask that, or I can dive into an answer.
Hi, yeah, I'll ask the question. Your definition of what's in production, I think, is a lot broader than what people traditionally think of. So I have lots of projects into production now based on your definition. And what are your thoughts on meshing that definition with the more traditional one where it's more IT focused? And I think this friction comes up a lot more often than
Yeah, let
potentially I
me
realize.
find you. I have a slide that from another talk, which I decided to not include the slide today, but it's very relevant. And I'm talking about, I think this distinction is so helpful, it's useful to make, that there's R in lowercase p production and R in uppercase p production. And uppercase p production is like often what people are talking about, where it's like something is so mission critical to your organization that if it stops working, you'll get paged, right? If it stops working at 3 a.m. on a Sunday morning, you will get woken up and you will need to fix it. And most of the time, like most data science stuff does not go in that level of production. And so while I think you can put kind of R in this like uppercase P production, you don't actually want to put your data scientists in uppercase P production because they don't want to be woken up at 3 a.m. in the morning. Like that's not kind of what they've signed up for as data scientists. So this kind of lowercase p production, which is more about like it's running regularly, it's running on another machine, like that's great. And because like every organization, if you look hard enough, has like Excel running in production, by which I mean there's like some critical Excel sheet that is regularly looked at, regularly updated, and if it broke, like senior people in your organization would be pissed off. So if you can put Excel in production, like in that sense, you can certainly put R in production. And I think a lot of it is just trying to figure out like a lot of the challenges around like vocabulary and kind of, people in IT and data science use the same words to mean different things. And I think a lot of it is like trying to figure out how to have like productive conversations about these issues. But yeah, definitely, I think like definitely a challenge because people think like it has to be this like big all or nothing production thing. And Tarif has this really nice analogy, which is like, production is like going out, like capital P production is like going out for a restaurant meal where it's been prepared professionally by chefs. And that's great, but that doesn't mean that like home cooking isn't great as well, right? And so you're like many data scientist dashboards, it's more like home cooking. It's not like the professionally prepared food / dashboards. It's like running your organization. Maybe it's only looked at like once a week by a handful of decision makers, but it's still useful and it's still important. It just doesn't need to get to that same level.
Thank you.
Should we take one last question, you think, Federica?
There are two questions we haven't addressed. Like, what do you think about the R code generated by GenAI, and can we use the code for the production? And then USDA and ASS embraced R within the last 5 years and added nearly 200 internal users. It's going to be okay. So that's not, if any of you would like to answer the last question to Dr. Hadley, please do it. So this is your chance before we end this meetings. Okay, so I think it's just what's about generative AI? What's gonna, so
Yeah.
you already mentioned something, but
yeah, again, I don't know. I would say I'd encourage like everyone to like try it out, whether it's via like Copilot or ChatGPT. It feels like it's going to be like I don't know what impact it's going to have, but it feels like the impact is going to be big. I'm using it in my code. It's I don't know. It's kind of interesting that it's not. Sometimes it's really annoying because it keeps suggesting things that I'm like, that's not right, and then it's just something else, and I'm like, that's not right, and then I'm just like, just stop, shut up, like you're distracting me. And other times, it's like, and it's really good at writing sort of boilerplatey code in a way that I'm like, is this good? Because it just lets me, like, instead of kind of copying and pasting, it just sort of splats it all in. And I'm like, well, if I had to write that by hand, I'd probably like rethink it a little bit more, but it's already written, so I'll just keep it. It's, yeah, I don't know. It's really interesting. I think I would, and I don't know, like, how, like, you know, I've spent a lot of time writing R code. And so I can read the R code and pretty quickly, like, assess, is this good or not, or is this likely to do the right thing? Although sometimes, even that, given that sometimes it tricks me because it gives like the name of a function or the name of the argument that just seems so perfectly suited for what I wanted to do. I'm like, oh, how did I know that that didn't exist? And then I run it, and the reason I didn't know about it because it doesn't exist. So I don't quite know, like, I find it really useful. I don't kind of quite know like how it works if you're not as familiar with R code. Like, how do you assess the quality of it? Like, how do you know if it's doing what you want it to do? But I think overall it's like it seems like a big win. Like, it lets you kind of rapidly explore things. I use it a bunch when I'm working in programming languages I'm not that familiar with or don't use every day. Like, it allows you to get something on the page and then iterate, which I think is incredibly powerful. So I think my main encouragement is just, like, you know, try it out and see how it works. See how it works for you.
Yeah, big changes. So, okay. I think it's time is up. Thank you very much. Thanks for your time and to be here, so accepting our invitation, be so kind, and everything so went so well.
Yeah, thanks so much for having me. Have a good day. Good evening, everyone. Bye.
Thank you so much. Bye-bye.
Thank you.
Bye.
Bye-bye.
Bye.
Bye. Thanks. Thank you.
Thank you. Silvana.
Ciao Federica.
Ciao. Mamma. Bene.
Thanks so much. The recording might go to my cloud. If it does, I'll share it with you, Federica.
Okay, that's great. Because
Yeah.
I have two parts, so I just restarted this one, so it's still recording, so I should stop.